a little bit of trig derivatives, but mostly practicing product rule, chain rule, and quotient rule. Okay, so speaking which, we got a product. Well, sorry, we got a chain rule, because we got an outside function, sine, and an inside function, 3x. So the derivative of sine is cosine. Fine. That's not that hard to remember. So the derivative of this is going to be cosine of thingy, and then chain rule. I always draw the arrow. Okay, this is a product rule. Derivative of sine is cosine times the second thing plus the original first thing times, what is the derivative of cosine? No, the derivative of cosine is negative sine. Fine. E to the tan x. Remember, the derivative of e to the x is e to the x. So the derivative of e to the thing is e to the thing times the chain rule. Chain rule is always a real live multiplication, not up in the exponent. So not up there. What's the derivative of tangent? Secant squared. Proof on the back. Fine, whatever. Product. Chain first, and then times the derivative, times the original second thing. And then the original first thing times the derivative of the second thing. Derivative of sine is cosine. All right. Oh, look, a product. Okay, derivative of the first thing times the original second thing plus the original first thing times the derivative of the other. What's the derivative of 2 to the x? I'm going to let it slop over and draw a little arrow for the next one. If the base is not e, it's like e to the x, but with a multiply by the ln of the base. Okay, and then what's the derivative of 5x? It's 5. Okay, a little practice with the quotient rule. Let's do that. Okay, derivative of the top. Ew, all sorts of nonsense. So negative sine of thing times the derivative of thing. Derivative of e to the 2x is e to the 2x times 2. Oh, look, it's a triple chain. Times the bottom. We haven't even gotten that far yet. Minus the original top. Times the derivative of the bottom is 3 to the x ln 3. I'm going to put this up here so I don't run into my markers. All over the bottom squared. Aren't you glad you don't have to simplify these? Okay, so a little bit of proving things on the back then. Okay, what's the sine angle addition formula? Sine alpha plus beta is sine alpha cosine beta plus the other way around. Okay, and we're going to take these sort of on faith for the moment, that this limit is 1 and this limit is 0 if we are in radians. The right-hand one is still 0 regardless, but if we're in degrees, it's not quite right. So I'm just going to write a big long note on the right there. Let me see if I can get this thing on the way. Yeah, it doesn't want to go. Sometimes it doesn't want to go. All right, never mind. Oh, it made it purple. Oh, that's okay. So being better. Okay, for those of you who listen, I will tell you, to get from degrees to radians, you multiply by pi over 180. I wonder what that is in decimal form. Okay. Definition of the derivative. Every time we take a new kind of function, we got to go back to this definition. Okay, sine angle addition formula allows us to split up sine of x plus h. So parentheses. The first and last terms both have sine x, so I'm going to put them next to each other. And just write it as okay, split it up into two separate fractions. Okay, so what have we got? We have this up at the top was 1 in radians. And this, regardless of no matter what, is 0. So we just have cosine x. All right, parentheses. Okay, so the derivative of cosine is very similar. Yeah, we'll take it on faith. Quotient rule to show the derivative of tangent is secant squared. Why is it a quotient? Because tangent is really a quotient. Derivative of the top times the bottom minus the top times the derivative of the bottom. Oh, look, double negative all over the bottom squared. What is cosine squared plus sine squared. Do you remember from last year? It is 1. And what is cosine? Well, 1 over cosine is secant. Oh, yeah. So we got secant squared. There you go.